Today we'll be learning about Boyle's Law, which was named after Robert Boyle, not to be confused with Susan Boyle.
I dreamed a dream in time gone by.
So today we should be able to state Boyle's Law, sketch graphs of Boyle's Law, and apply Boyle's Law to solve problems. So Boyle's Law says for a fixed mass of gas at constant temperature, the volume of the gas is inversely proportional to the pressure. So this graph of Boyle's Law here shows a curve. Why is there this curve? Well, as the volume increases, the pressure then decreases. So it curves downward like that as volume increases. And then as the volume decreases, it curves upward because the pressure increases. Remember that if there is an inverse relationship, when one increases, the other decreases, and vice versa. Here, this other graph is a graph of pressure versus 1 over volume. So if the graph of pressure is plotted against 1 over volume, you will get a straight line passing through the origin. Why is this so? Because although pressure is inversely proportional to volume, that then can be stated another way such that pressure is directly proportional to the inverse of volume. So the inverse of volume is 1 over V. Just like in basic mathematics, what is the reciprocal of 5? The same as the multiplicative inverse of 5 would be 1 over 5. So now we come to some examples.
A tire with a volume of 11.41 liters reads 44 psi, pounds per square inch, on the tire gauge. What is the new tire pressure if you compress the tire and its new volume is 10.6 liters? Write out Boyle's Law and substitute in what we know. This is one of those before and after situations, so we write P1V1 equals P2V2. 44 psi times 11.41 liters equals P2 times 10.6 liters. Solve for P2. Divide both sides by 10.6 liters. 44 psi times 11.41 liters divided by 10.6 liters equals P2. P2 equals 47.36 psi. There are two significant figures in the measurement 44 psi, so we round our answer to 2 sig figs. 47 psi. Here's another example. A syringe has a volume of 10.0 cc's, or 10 cubic centimeters. The pressure is 1.0 atmospheres. If you plug the end so no gas can escape and push the plunger down, what must the final volume be to change the pressure to 3.5 atmospheres? P1V1 equals P2V2. 1.0 atmospheres times 10.0 centimeters cubed equals 3.5 atmospheres times V2. Solve for V2. Divide both sides by 3.5 atmospheres. 1.0 atmospheres times 10.0 centimeters cubed divided by 3.5 atmospheres equals V2. V2 equals 2.9 centimeters cubed, or 2.9 cc's. Boyle's law relates pressure and volume.